Michael,
Good afternoon, Jan.
do you hear me?
I hear you. I do not see you.
Okay,
Okay.
now it works.
Yes.
There was something strange. He told me join voice. Michael is in voice, join voice.
Yeah. They call these voice rooms, even though they've got videos. I'm not
Yeah,
really
but
sure why.
normally I press on the camera and then it joins the session. And now the camera is not there.
Hmm.
And then you didn't see me. And afterwards I could press the camera. You probably made another update.
Yeah, probably.
Okay.
Yeah, they've been trying to make this platform easier to use. Where'd things
Yeah,
go? I don't know.
probably for new people, but okay. It's not because at the first look it's worse than it will be worse. I always remember Windows XP.
Oh
When
wow.
I
Yeah.
saw Windows XP for the first time, I said, "What is that? That's something for children to play with."
Yes. Yeah. All candy
And
colored and yeah.
and Windows XP has been the most successful, longest-lived version ever.
Mm-hmm.
I still have it running on some virtual machines. So
Wow.
it's not because it's a bad thing at first sight that it looks
Yeah.
bad.
Yeah, and I remember I was working at a retail company, writing their point of sale software, and so they would have the point of sale machines come into the office in order to perform updates, and then they would send them back to the stores. Um, you know, very inefficient. I mean, over the air would have been better, or at the very least, you know, somebody trained out there. But yeah, they sent them all in. So there was an entire month where I just heard the Windows XP boot noise as they were updating the operating system. It's like, oh
Mm.
my goodness, how many times can you just turn the speaker off when you start it up, please? Oh goodness.
Oh, that was still a while ago then.
Yes, yeah, it was a while ago.
Yeah. And unbelievable that it has to be done that way.
Yeah,
But
yeah.
okay.
I guess a full operating system probably is not quite so easy to do over the air, but
No,
it's.
because you lose access if you
Mm-hmm.
uh, unless you use these special dongles like what is it that take over your screen
Mm-hmm.
uh, through the video port. But even that is not working perfectly. So
Yeah, yeah. Machines weren't designed to work that way. Yeah,
anyway, updating an operating system. Uh, Not many computers live that long.
yeah, yeah. True.
Uh, Once you update them, I always try it and I always do it for myself. But from a financial point of view, on efficiency point of view,
Mm-hmm.
I think it's better to throw it away and buy just a new computer with a new version of Windows.
Yeah, yeah, yeah. I've updated to Windows 11 on my laptop. This machine right here, my desktop rig, is still running on Windows 10. Um, and I built this one myself. I don't know if I'm going to completely rebuild a new one for Windows 11, but at the very least, I'm just going to take the hard drive out, put in a new hard drive, and start from there.
Mm. No, my computer is also Windows 10, my main computer, because Microsoft doesn't allow my CPU, doesn't like my
Hmm.
CPU for Windows 11.
Hmm.
It was just one of the last ones which appeared before.
Uh, is it lacking a hardware encryption module or hardware? What are they? HSM, hardware security module.
It, something like that, I don't
Yeah.
know. They had a so-called reason for it. Okay,
Mm-hmm.
fine.
Yeah.
Windows 10 is working fine, and they are still supported until 25, I think.
Hmm.
I think 2025, I think. And by that time,
Yeah.
just buy another computer.
Yeah. Yeah. Exactly.
Yeah.
Yeah. Windows 3.1
Okay.
just dropped out of support. That seemed kind of fast to me, but hey, yeah, move everybody from Windows or not Windows 3.
Windows 10.
.NET 3.1, .NET Core 3.1. Goodness, Windows
Mm,
3.1. Wow, that was a long time ago. Anyway,
3.1 and 3.11.
yeah,
Yeah. That's a long time ago.
Indeed.
Somebody
Good
joined.
morning, or good. Let's see, Faust. Where are you joining us from? What part of the world?
St. Cloud, Minnesota.
Oh, Minnesota. Okay, so then it is good morning to you.
Yes, it is.
Very good. Jan is in France, so I always try to remember to wish him a good afternoon.
Oh, well, good afternoon.
Thank you. Good morning to you. Um,
Very good
I was
to see
recently
you.
in France, but only for a long layover. But yeah, but it was a lovely airport.
Airports are not the best way to enjoy life.
Well, I did go to the Air France salon, so it was a better way to enjoy life than in the terminal. But anyway, there's more
Yeah.
to France than your salon.
Mm.
Yeah, my daughter's been to France, but I've not. She and her arts class in high school took a field
Okay.
trip, saw the Louvre, so they did the whole Paris thing. Yeah, never made it down as far as you, but yeah, one of these days I'm definitely gonna check out Paris. But then I'll take a train and I'll come visit you.
Come and visit me. We can have a nice chat here
Yes.
about historical modeling uh, with some food, some drinks. That would be nice.
Yes, indeed.
Mm.
Yeah. So uh, well, I'm addressing you as Faust. That's your handle. Do you have another name you want to go by?
No, actually, Faust is the name I go by.
Okay, cool. All right. Didn't know if that was just a callback to the opera or whatever, but welcome. So have you started reading the book?
I have started reading the book.
Yeah, and how far have you gotten in?
Not far enough.
Oh.
So I would say that I'm still in part one,
Hmm.
and I thought I had done fairly well. And then I went back to the beginning to read, and then I picked more up.
Mm.
So it's I'm working on a project where and so that's how I came across your book.
Hmm.
And so a lot of this is new to me. And so I just thought, well, I better get it down. And I think what helps is the more I try to explain it to my boss and other folks, the more I realize, yeah, I need to read this again so it sounds comprehensible when I talk about it.
Mm. Okay. Yeah. Yeah. Chapter 4 is the real the real milestone. So once you finish chapter 4 and think you've got everything, then the rest of the book is just details. That yeah. So um, what kind of issues are you trying to use these techniques to solve?
Well, we currently have, I work at a college, and the advancement fundraising arm is moving from one um, ERP system to another.
Hmm.
But the college itself is still using, I'll just use the names of the things because it gives them a name and it keeps me from saying one or another.
Yeah.
The college itself will still be using Colleague for maintaining a bunch of records, such as students and parents and employees. And there's overlap between that information and the information that'll be in the new system, Slate. And of course, there'll be a bunch of people in Slate that are donors that the rest of the college doesn't care about within Colleague. And they initially had said that we'll just figure out which is the system of record for which bit of information.
Hmm.
And then it became clear that, and so that felt to me kind of like, well, then that's a caching thing, and there's a clear rule. If it comes from this system, even if it changed in the other one,
Hmm.
if it's in Colleague and we said that was the system of record, it wins. We just
Yeah.
override it. But then it became clear that what's going to happen is we're going to get changes in both systems and we'll need to reconcile them. And then they were trying to figure out how to, what the rules would look like. And I said, well, this is getting more complicated. I
Hmm.
mean, we do have a case where it's a very easy thing, like when Slate creates its ID for something that was in Colleague, right? That's a clear, well, Slate is the system of record for its own identifier. We can just do a direct message to colleague and say, update that field.
Mm-hmm.
So then I thought maybe I needed to model, not quite in a DDD way, but a person, an independent person object that had the information that we'd want in both systems. And then when I started doing that, which I know isn't quite proper DDD, but at least I was thinking, well, we need for the business, what is a person? And then we can take inputs from both these systems, figure out what is really the person based on our rules, and then send the updates to the other two systems as we see fit. And as I was doing that, that's when I started searching for more books and like, well, this is a much more complicated project than I
Yeah.
initially had thought. And it's just a small piece of it. And one of the things we were going to do is I had found an old tool called auto audit for SQL Server.
Hmm.
And there was no real way to within the two systems, they kept wanting to rely on update dates for sort of knowing when we needed to invalidate the cache on a certain record.
Right. Yes.
But the update dates were not that useful, because what happens in some cases is if something is updated on one person's record, it may go update the other records, even if it doesn't update any actual values, because it recalculates different things on the relationships.
Oh.
So those date flags get hit.
Yes. Yeah.
Unlike, I think, in your code at one point I saw where you checked before you made an update that there was an actual change in value for that field.
Mm-hmm.
And auto audit luckily does the same thing. Before it shows that there was an audit, like an auditable change, it checks to make sure that the update is an actual update.
Right.
Now, in your
yeah.
case, immutable, what you're doing is before you're doing an insert of a duplicate value, right? So instead of doing an update, you're doing an insert. So I'm
Mhm.
showing you how little I've got of your language, but then that made sense to me, and I tried to explain it to my boss that because in one way this sounded like, oh, this seems like a lot of work, and I said, well, I built a data warehouse for giving, and in some ways, if you think of what you would refer to as a projection, I
Mhm.
do that every night, because instead of just changing the amount that someone's given in a lifetime or the status of a pledge, I thought I was being lazy when I did this, but I just went through, I started at
Yeah.
0, went through all
Mhm.
the transactions, and said, this is what they gave.
Yeah.
And I started at 0, and they made a pledge. Here's all the payments to it. And this is the current status. So every morning in the data warehouse, they have a projection built from kind of immutable data in that way.
Mhm.
So I tried to explain we are actually doing something similar to this.
Right. Right.
And then that's my long-winded way of telling you where I am, and then thinking you can tell me if I've jumped into something deeper than I need to, or if no, this immutable data sort of strategy makes sense.
Yeah. Yeah. I think it does. That idea of changes can come from two different places. That's really the entry point, where you really do need to think more deeply about data management. So yeah, I think you're starting in exactly the right place, and I think you can apply the ideas of historical modeling and immutability in a certain subset of your application, and you don't have to just say, oh, okay, everything's got to be immutable, so let's just rewrite the whole app. So it can be focused around this idea of the person. Now, kind of as an aside, I've noticed that the concept of person is often, that's often where trouble comes. I mean, people are trouble, right? But
They're mutable.
Yeah, very mutable, very squishy. You can't even tell if it's the same person sometimes. It's really weird. So yeah, I was working on a system that was for forensics, and it had two halves to it. One was cases of missing persons, and then the other side was unidentified remains. And So part of it was, let's gather information on these missing persons cases, actually crowdsource that, let some of that information be visible to the public. So really cool application. I really enjoyed working on it. And then the other half of that was of course, do these unidentified remains kind of match up with one of these missing person cases? Can we kind of close both of them at the same time? Which is an unfortunate way to close a couple of cases, but that's kind of the reality of the domain. And so intrinsically in the domain, you've got a concept of a person. Missing persons case is about a person, and so one of the temptations of the team was, well, let's define this person object, and so unidentified remains is also a person, and then our goal is to just figure out if this person is the same as that person. And as it turns out, on the other side, it doesn't really make sense to abstract that person idea, because as you dig into it, you realize you have so little information about that person on the unidentified side that any object that you create, a person has a name, they have a date of birth, they have a gender, all of these things, and you realize, I know almost none of those things about these remains. And in fact, sometimes a record on the unidentified side turns out to be animal bones. Sometimes you've got remains in different areas, and so these were both actually related, and so two records become one person. So it's all sorts of weird kind of things to try to say, okay, that's a person. And I think an even bigger temptation in the system was that it was also about law enforcement officers and about people in the public who were giving this information, trying to follow up on cases. It was other people in the forensics area. So who studied the fingerprints, who studied the dental imprints, and so you had people all over the data, and in a lot of cases, it was important to know that person's name. So it's like, okay, well, wouldn't it be interesting to be able to just index a person and say, okay, this law enforcement officer is involved in these cases, so that if you get something new here, you can notify them. So let's make law enforcement officers a person. Let's make forensics experts a person. And so it kind of abstracted that idea up even further. So it turned out to be a not a very useful abstraction, and one that really did kind of muddy the waters. So my hope for you is that the abstraction of person that you were just talking about there is something that first you can identify this specific person, and then secondly that it is a person with a given role and limited in that scope.
Mm-hmm. Luckily, most of our donors don't have many unidentified parts, but that we're trying to match up. But no, I mean, I think we could run into issue. Luckily, on the new system, in order to create a record, you need name, birth date, and email. So I know that at least for that system, defines a person there. The previous system, you can have less, but you at least have a name.
Mm-hmm.
We may not have a birth date or an email since it's a historical record, but it's unlikely to be an active donor anyway. But you're right, there could be issues with person. And maybe I need to think, instead of thinking of person, maybe I should break it down to donor or employee. Actually, that might make more sense because the rules for employee are going to be different than the rules for current parent or student.
Mm-hmm.
So maybe instead of being super vague at the person level, and this isn't exactly what you said, but maybe what I was getting out of it was maybe instead of person, it should be a law enforcement or investigator object and not we're all people. They
Yeah.
are, but that's not as useful.
Right. Yeah. Yeah.
Is that what
Exactly.
you're saying?
Yes. Yeah. Precisely. Yeah. I think that is going to be helpful to you. And some of the pushback that you might see to that is, well, what if a donor is a former student? Yeah,
Yep.
shouldn't they be the same person in the database? And um, so so yeah, you respond to that with what benefit? How does it help us to know that these are actually the same person? What's the harm in having two different records for that person? Which could uncover some hidden requirements, and then hopefully you can find a good way to implement those requirements without recombining those two ideas. But yeah, I think it's really important to realize that when you rate software, you're not reproducing the real world. You are modeling the real world, and the model is incorrect, but it's useful.
Okay. Now that is helpful, and of course I was tempted by person because both
Mm-hmm.
of our tables with that base info is called person. So
Mm-hmm.
it's the first thing I jumped to. So I did reveal that I did like some C4 system context diagrams for my team to give them an idea of where the problem's coming from and how this is more of a distributed system than well, this one's just getting the info from here and this one's getting the info from there, and we have no issue. And I guess not to go on too much of a tangent, I found like the discussion both in the one podcast from you I listened to and in your book of oh, what are they? It's not called the myths of distributed systems,
Oh,
but
the
those 8
fallacies.
fallacies,
Yeah.
yes, were helpful to go through. And then when you would note, oh, and here's where this fallacy comes up. And every time I think I don't have a two generals problem, I think through it. And then a little later, I realize I kind of do if
Mm-hmm.
I don't relax some of my constraints that I may not need. So how would what issues are you likely to have, since I hadn't thought of letting someone be both I mean, they can be both an alum and a donor,
Mm-hmm.
but I might have two different objects for that same person.
Yeah. Um, so one of the challenges you might run into is that if you can log in as an alum and you can log in as a donor, you want that person to just have one login, and then to get those two experiences. Um, so um, so really abstracting the idea of this is a database about a person versus this is a database for a person to use. Um, and so if you log in, you really want to know, who is myself? Who is the alum that is me? Who is the donor that is me? So you can start branching out from there and doing your queries. Um, so you will probably want to end up with, if that's the case, an alum record, a donor record, and then they both have foreign keys to a user record. And then you end up with the challenge of I've got demographic data on alum and demographic data on donor, and if somebody logs in and wants to update their name or their email address or their mailing address, they should be able to just update it in one place, but I've stored it in two different places, and so there you're starting to break it apart again and say, well, some donors have user records, and so those users can update that profile information. Other donors, they never log into the system. Somebody else entered them, and somebody else is updating their demographic data. So that becomes one of the challenges there. Yeah, that's one of those it depends moments where you have to kind of figure out for the specific set of requirements that you're solving for, what's the best way to organize that data. Yeah, I don't have a clear answer for you there.
So I was envisioning, since both systems sort of have figured out how they're organizing some of that data, and since I got pushed into learning Python for this job, I was envisioning a Python application sitting between these two to help sort out the data and the rules. And the way they work, this would not be super real time. So it's not like there's going to be long time delays before, because I'll have to do polls from each, likely, unless I figure out a way to have the DBA let me write triggers, on these databases. So I was also so I have that where I just have a traffic cop, dealing with old information, old at least, within the last 24 hours. And so I was also intrigued by the idea of what happens when updates are made in both systems within that time. And of course, my boss had more of in her mind what I'm guessing would be the first model you have, which is the event sourcing that relies on temporal order. But it sounds like the historical model doesn't need to be as ordered in that way. Like you had talked about, but somehow I have to keep the commutative property of the updates. I'm wondering if you could help someone who's trying to work through that and how to explain it, and I guess understand it. That different, because you had like an example of sets, right? Where like this is greater than this is greater than this. We may not have to sort them all in counting order, but somehow we have some sorting going on.
Right. Yes. So kind of bringing it down to practical. I mean, of course, I love talking math and say, because that's the only way that you can say something and have it always be true. But yeah, taking it down to practical. If you think about these two sides that you're synchronizing and just keeping them separate, now you think of each one of these as a separate replica of the data. What you're doing when you just say we're updating a phone number. That's just keep it simple there. What you're doing when you update a phone number on one side is you are inserting a record that has a foreign key back to the previous phone number. And then on the other side, you update the phone number of the same person, so it's got a new record foreign key back to the previous there. So now when you bring them together to compare, you can see that those trees branch. That if you were to run a query, to just a SQL query, give me all phone numbers such that there does not exist another phone number that points back to me.
Right.
So then if that query, then now you're going to be grouping by the actual individuals, like the donors, for example. So group by donor, and now for any donor you end up with two such records, then you know that there has been a conflict, that there's been a concurrent edit. And so the way that I prefer to implement that when I have the chance is to allow that concurrent edit to be visible on both sides, just like in Git when you fetch a branch, that branch is visible right alongside your branch. You see both of them, and so then on your replica you can decide how to resolve them. You could just leave them as separate branches for as long as you need to, and then you can perform a merge, and that merge is something that you do on your side and then share with everybody else. But there's no automatic merging in Git, so I prefer to, when I have the chance, make it such that there's no automatic merging in these systems as well. And then that probably will be a change to the to both of those systems, right up to the user interface, is that there's usually just one field for phone number. So I'm assuming that in this example that there's just one phone number. If there are multiple phone numbers, similar strategy applies, but with a caveat. But So I prefer to change the user interface so that it somehow indicates, there's a concurrent edit here. User, help me resolve it. So one one strategy that you might employ, since you know the topology, now you can make a deliberate and informed decision about relying upon that topology. And that's a decision that I try to avoid, because first I push it off to the user, say user solve it. But if I absolutely can't do that, then I'll say, okay, I happen to know that this one machine is the connection between these two services, and so I can build the rule into that one machine, but then recognize that it is inserting information. It's creating new records when it makes that determination. So, if you see a tree that has 2 leaves, and you decide to put the conflict resolution in one place and have that be automated, then it's going to push and insert back to both of the systems, basically like a merge commit, back to both of the systems, saying, no, I have decided that this is what the shape of the data is going to be, and raise that flag. People should be able to see that a machine has made a decision that a human should have made, and then go in and evaluate whether it made the right decision.
So I can push that decision back to the user, like Git does, or I can try to automate it, but there I should still kind of put that back to the user to say, was this right?
Yeah, and it might be a different user. It might not be somebody who comes along later and looks at that particular record, but it could be somebody in operations who comes in the morning and sees a report of, this is the conflict resolution report for the night. And then they just say, okay, let me log in and make sure it looks like these 2 phone numbers are just transposed from one another. So let me actually look it up, research, figure out what the right one is, or call people up, or whatever is necessary to resolve the issue. But yeah, given that you're working with legacy systems, sometimes you do have to make those kind of compromises.
Okay, well, that's helpful to think through, and of course, I mean, it's I'm not at the level you guys are at with this sort of stuff, but yeah, of course, the users would like it automated, and my boss would like me to spend as little time as possible, but keep it accurate. And so I'm guessing that this is probably a case where, similar to when I've got a conflict in my, in Git. No, someone's got to go in there and figure it out and make it right.
Yeah.
And so the app isn't going to be magic.
Right. Exactly. There is no magic.
If we have edits on both sides that conflict, someone's going to have to resolve it, or they're going to have to be happy. This rule's resolving it, that may not be right. And then it'd be good to have a report for them to see. This is what happened. This is how it was resolved. Might want to go fix that if it doesn't look right, or verify it. Okay.
Yeah. I think the important part of that is that the database would have to be redesigned to know how to represent a conflict. Whereas if you have just a donor table with a phone number column and then another column that is your updated date, there's not enough information there to know that there was a conflict, because the updated date applies to everything on that row, and you don't know what the previous phone number was, and you don't know how that's causally related to the other change that you see on the other side. So the most important thing is break apart the data model so that it represents the data accurately, and that's where you introduce the immutability. Then the rules that you apply on top of that have a chance of being right, or at least being useful.
Mm-hmm.
Cool. thank
So
you.
in your book, you talk about that user, like that case where the user has to go in and
Uh,
conflict.
yes, I'm trying to think
Well,
where that
we'll get
was.
to it.
Yeah.
I guess looking for spoiler alert of
Yeah, it might not be until chapter 8 where I get into the patterns, because one of the patterns that I talk about is the mutable property pattern, and um, so I believe that in there I do talk about in the consequences. Yeah, concurrent changes cannot be prevented, um, and so yeah, I think in there I do talk about um, the user being the most the most intelligent and the most informed actor in the whole system, and therefore the one who should determine what happens in the face of a concurrent edit. Yeah, yeah, and now bringing the math back in, because I can't go long without that. Um, the term conflict is something that you often use in these scenarios, but if you are modeling things immutably, then you can actually become conflict free. But that doesn't mean that this situation won't arise. It's just we've redefined the word conflict. Um, so yeah, a conflict
now it sounds like
is
you did philosophy.
what's that?
Now that sounds like you did philosophy. Well, we just redefined the
Yeah,
term.
yeah.
But go on. Let's
Solves all sorts of problems if you just redefine your terms. But yeah, when we talk about a conflict-free replicated data type, for example, that means that all of the nodes, all of the replicas, eventually agree on what happened. And what happened could have been a concurrent edit. But if everybody agrees, then there's no conflict. Um, so yeah, in Git is conflict free, but yet, hey, wait a minute, there are merge conflicts. So yeah, it's that people made concurrent edits to source code that are incompatible by the rules of source code. Um, but there's no conflict because both of the people can see that there are two different branches. And then if they were to try to merge those branches, then the automatic merge that takes into account the rules of source code, or at the very least the rules of text files, then it wouldn't be able to come up with a single projection that represents the intent. So yeah, we've redefined conflict to make the math work out better. So so that's why you'll sometimes hear me hedging and trying not to say conflict and instead saying concurrent edit. But yeah, that's what I mean there.
Okay.
All right. Yeah, thank you for that. If you want to reach out to me and introduce me to your team, I'll be glad to to kind of go over some of these concepts and give you some support there.
Thanks. And so when I get further down, how useful do you think it would be for me to look at your open source project that tries to make this get some of the back end stuff
Yeah, yeah.
out?
So yeah,
Yeah.
the Festify project, I believe, is the best place to look when you were trying to apply these concepts using existing technologies. So that's a really good place to introduce people to the concepts. The Janaga project is when you say, okay, I'm all in, and I'm going to use a brand new technology stack. And then it can solve a lot of problems for you. But yeah, I would not, certainly at this point, I would not introduce Janaga to a new team as a way of saying, okay, here's how we're going to solve it, and just rewrite everything on top of Janaga. Yeah, maybe maybe when Janaga is more mature, I could start to recommend bringing in Janaga to be that middleman that you were just talking about. So it knows the two sides and then can convert those into historical models, keep those up to date as it watches for changes in the two databases, and then use Janaga to synchronize. I don't like that word either, because synchronize means time, and these are not time based. But to bring those two models into into agreement. Yeah, replicate. There you go. There's the word. Yeah, replicate changes from one side to the other.
Thanks.
Yeah, welcome. Cool. So yeah, speaking of Janaga, I have made some. The last time, Jan, that we spoke, we uncovered a bug in Janaga JS. So that is fixed. So I can demonstrate that fix. Do you happen to have any updates on the Janaga.net sequel?
I let myself carry away after your nice video with the papers of Mark Sphero again.
Mm-hmm.
Read some papers, looked again at some videos of Martin Klapman.
Yes.
I spoke about him long ago, but it's more of my favorite than Mark Sphero, because he's a scientist and a software developer at the same time.
Yeah, he's
And I think
extremely practical.
Yeah, he's a very intelligent guy, I think, and he's doing both at the same time. And he has a little bit the same problems that we are seeing with Janaga, I think.
Mm-hmm.
But it's very nice. And then I also started walking through the specification parser, so stepping through the part where I don't have to be, but sometimes I like to let me carry away by it. But then I got to something where I probably didn't pay attention when you explained to it. If you go to the specification paper, there in the last example, you have, because that's an example I found of it, because I first, if you go to the source code of Jinaga's server, probably Jinaga itself, because if I step through it, I end up in the JavaScript file. Specification parser.js, line 104. Where was it? Let's see if I can find it back immediately.
And let me get to where I'm sharing so that we can all see.
I didn't put. Perhaps I put a breakpoint there. No, I did not. Oh, yes. Specification parser. And then line 104. 104.
Yeah, I happened to actually just be in this code last night because I found a bug in the parser. So
okay,
no, you re-upload this data.
Yeah, no, you are in .NET now.
Oh, you're talking about the JavaScript version.
I was stepping through in JavaScript.
Oh, okay. Well, that one's better.
That one
yes.
at hand, or
yes.
You want me to show it?
Yeah, I've got it.
Okay.
There we go.
I got in the translated model, the GS. Anyway, there is a routine which is called parse path condition.
That one there.
Yeah, and there you see one to one. It says the roles right. Yeah. So there the parser is first gonna find the left roles and then the right roles. But these right roles, what do they mean? Because there is, so in the specification paper, the last example has an example of that. Yeah, so
Yes.
you have there, yeah, that one.
Yeah.
Is equal to assignment, and then it has this project role.
Yes.
But what does that mean?
So it's the difference is really just this is left rolls and this is right rolls. So what it means is so first of all the label that you start with on the left always has to be equal to the unknown of your match, and then the label you start with on the right is one that's previously defined by some previous match or by
the given or a previous one.
Yeah. So in the model, I'm just capturing the label right. I don't worry about capturing the label left because that's given from context, and then the list of roles that are on the left and the list of roles on the right.
Yeah, but so the role, if you go back to the specification, just the meaning of the specification, because the left one is clear. You look for all the tasks that have a role that projects it to that links it with the assignment. But the role on the right, that project,
Yeah.
what does that mean in the specification?
Yeah, it means the assignment points to a project and the task points to a project. So this is selecting all of the tasks that point to the same project as the assignment does.
That okay? So and then the assignment. No, the assignment is not an unknown because we have.
Yeah, the assignment is defined as actually up here.
Yeah. So you have a project, you have an assignment, and you are looking for a task that. So it's actually go up, go down.
Right. Yes. Exactly. Exactly.
Okay.
Yeah. So this user is assigned to several projects. So you've got those assignments, and now you're looking for the tasks of those projects. So from the assignment, go up to the project and then back down to all of their tasks.
Okay. Yeah.
And so in a lot of cases, like in this one, you have just roles on the left, and so right roles is going to be empty. And sometimes the opposite is true. I don't have examples of the other one in here. Yeah. But
always when I when I was not sleeping, it was always on the left. And so there I found in the code, I say a label on the right, but how is that possible? And then I went searching in VS Code for one example, and I got to this one. But apart from that, I didn't find any example of it. Okay, so that is clear. Okay, and then there was another one. Not a question, but one of the advantages of historical modeling, and I don't remember that seeing in any of the papers or any of your documentation, is actually that it respects transactions.
Yes.
I don't know whether you put it on any slides. I don't remember seeing it, but the fact that you, for example, if you have somebody wire transferring from one account to another one, in classic systems, you will send an operation, take the money from one account, then you will send a second operation, save it on the second account.
Yeah.
Both of these operations have to arrive at the same time at the other replica. Otherwise, the money will be gone at a certain moment. While if you just define a fact, which says transfer from account A to account B, that fact contains all the information. And so once that single fact is replicated to the other server, all the information is there.
Yeah. Yeah, I don't think that I cover that in a lot of detail in the book. I know that I have that documented as a pattern. I think I happen to use that as an example in when you're deciding what's a predecessor and what's a successor. So that would be in analysis.
Yeah, the accounts are definitely in somewhere.
Yeah.
I remember that's where I took the example.
Yeah, I
But the
believe that would be
transactional,
valid orderings, 170.
yeah. But I don't remember reading the transactional advantage. And that's something where I long ago got into trouble with the sync framework from Microsoft.
Yeah, I can't spot the example right now, but I did have an example in there where I've got an order and order line. So I've got that behavior going on, and then if I say the yeah, let me label that. That way I can see that there are multiple order lines. So if I've got this model, then the order locks in all those order lines because they're predecessors, and so they are now part of the immutable identity of that order. And so I can't have additional order lines. And then there's the opposite. The opposite way of representing that is an order as the predecessor, and then order line being the successor. The multiplicity is implied on the successor side because you can always add a new successor, which is actually exactly the problem here is that if you have this order, you don't know that it's completely locked off, that you have all of the order lines. I think that's the example that I started with there, but yeah, the transfer of funds. I don't know that I actually did that example in the book. I might have, but I think I used that in a talk. But so if you've got account and then you've got a transfer that that goes between two accounts, so so you can say I'm going to so here I'm going to label this one with the role from, and then I'll have another predecessor edge 2. So yeah, now that transfer is a transfer from one account to another account, and so you if you know about the transfer, then you know about both sides, and so you can't learn about the debit without also learning about the credit. So yeah, now you can do a projection where you say, okay, from this account, get me all of the transfers from and to this account, and then add them all up, subtract them all up, and that's the balance. And so learning about a transfer then immediately changes both account balances. There's no way to have an in-between state. Yeah, that's, I don't think I actually have have called that out in any form. I don't remember presenting this graph.
But I think it's useful to add it to the slide with the advantages of the history CRDT.
Yeah, you're right.
Because not all technologies have that.
Yeah. This, by the way, is true of blockchain as well. You'll learn about a transfer. You can now update the balance of both accounts. Here the only difference is that that this one you don't have to have a total order of all of the transfers in order to compute the current balance, but you cannot guarantee that the balance is not negative. So one of the things that you can say about a historical model is that, or the history CRDT in particular, everybody agrees on what happened, but you can't say everybody agrees on what didn't happen. And so that's the difference there between blockchain and historical model. In a blockchain, you can say this didn't happen. So there was no transfer from this account because that would have made it go backward negative. But
here there might be a transfer fact that you have not received yet. Yeah. Great. That were the two things I wanted to add. And the third thing is that I'm still working on the .NET version. Actually, I was able to make some time yesterday, not the whole day, afternoon, and this morning. It was not enough, like usual.
Yeah.
And after this session, I will do some other emergency stuff. But I hope that by beginning of next year, I will have something working.
Yes. Well, there is there is a difference now, and I was actually working on this last night, so that's why it's in dark mode. I usually like to present in light mode, but so there is now a difference you will find in .NET. So there might be some merge conflicts, some concurrent edits between your branch and my branch. I've not yet even turned it into a pull request. I don't think it's quite to that level, but yeah, when we let me go to so I want to talk about the inverter. Yeah. Excuse me. So when computing the inverses, I found a few things that worked out better in JavaScript, and then I've backported them to .NET. So the JavaScript inverter and the .NET inverter look really similar now. But one of those things is this. Wait a minute. I don't think I'm looking at the most recent code here. Let me just make sure I've got the... Oh, yeah. There we go. So, in here, I have this inverter context. So basically I've collapsed a whole bunch of parameters that I was passing around through all of these recursive functions. I was like, oh, that's all part of one inverter context. So the context is just things like, what is the subset of labels that represent my givens? And what are the subset of labels, which is going to be a bigger subset, that represent my result? Let's carry the projection through, because that's always used. And then collection identifiers, basically what's the path that I took in order to get down to this particular part of the query. So I collapsed all those through, and that really allowed me to clean this code up, and yeah, so now it's more in line with the JavaScript code, and along the way I did some renaming. So I brought the names into better agreement. So I think, and this is probably the case where we're going to run into a conflict. I think the names that you've got that you're generating your SQL from are different from these. So a match. Let's see, unknown conditions. Let's see. Yeah, I don't know that I. Yeah, I'm trying to.
The same names as JavaScript now.
Yeah. That was the intent there. So yeah, I know that I had name and label used in different places. Yeah, we had target type and well, actually target type is still there in a role. Okay, yeah, this I really should switch to predecessor type to match the JavaScript name. Okay, so yeah, we're not completely there yet, but yeah, so these names may change.
Okay. Yeah, but no problem. If it becomes more clean and more clearer, all the better.
Yeah. Okay. And yeah, just to and then finally, just to prove that the bug is fixed. Oh, this one here is actually the on the .NET side the latest bug, but oh, it's in the watch spec. Yeah. So yeah, last time we created this test on the fly. Should notify results related to a different starting point, and in fact, it did. So now it does not. So let's run jest. And it passes, yay. So yeah, when I add a new office to the empty company, it does not change this list of offices for this company. Yeah, it just contains the office and the closed office, since I don't have a not exists up here. So, yep, okay. It's fixed.
That's
which took a lot longer than I thought.
Gone.
Yes.
That's good news. Okay.
Yeah. All right. Yeah. Well, I believe that is.
So this code is not yet in the main branch.
Correct. Yes.
Okay. Yeah, then I perhaps better wait until you got it into the main branch.
Yeah, I think so. It'd be really weird to, to merge this branch in, because it's not ready.
Okay. No, let's do it. Let's do it like that. Next week you will be there?
Yes. So yeah, next week I'll be here. I am out the following 2 weeks. So the first 2 weeks of January.
You're gonna swim.
Yes. Yes, indeed. I'm gonna
hopefully not swimming.
Swim the canal.
Okay. Then we see each other next Thursday.
Indeed.
That's after Christmas, so have a Merry Christmas over there.
Yes, yeah. Merry Christmas to you, and Merry Christmas to you as well, Faust.
Okay.
Thank you. And thanks for all of your time and all of your great information.
My pleasure.
And perhaps see each other again next week then.
Yes, absolutely.
If you,
Yeah, Faust. We'll be
Yeah.
seeing you next week.
It depends if I finish chapter 4 and have more informed questions. Otherwise, I'll probably just watch the stream to see what I can pick up from your guys' conversations.
Chapter 4 is a real interesting chapter, so it will take some time to read through, but it's a very nice chapter.
Oh, good.
Mm.
I look forward to it then.
Okay. Okay.
All right. Merry Christmas.
Merry Christmas
Post,
to you.
Michael, see you next week. Bye-bye.
Bye.